Okay, welcome to this lesson on right-angled trigonometry, and we've learnt about the three different trig ratios which basically are created when we take two of the sides of a triangle and we make a fraction out of them. And because there's three sides, we can take, if we were to take a pair of those sides in two at a time, we could do that three different ways, and that's why we've got three different ratios: sine, cosine and tangent. So we've used these different ratios, and hopefully by now you've come across situations where if you know to use it, you've got the adjacent and hypotenuse sides to use, you know, oh, I'll look at my notes and think I'll use the cos x formula. If you know you've got the opposite and hypotenuse, well, you're going to have to use the sine, and you can look in your notes and choose that way. But there's a kind of neat way that we've got to remember what the formulas are and to choose which one to use any time. And it served your parents and grandparents learnt this as well. It's called SOH CAH TOA. So what does it actually mean? What does SOH CAH TOA mean? Well, if you take all of the kind of first letters of each of the formulas, we've got S for sine, O for opposite, and H for hypotenuse, then we end up with the word SO, or the initials SOH, SO. SOH. So S stands for sine, O for opposite, and H for hypotenuse. If we look at the next one, we've got C for cos, A for adjacent, and H for hypotenuse, and that gives us the little word CAH. And the last one is going to give us T for tan, O for opposite, and A for adjacent, and that's going to give us TOA. So we get this nonsense set of words, SOH CAH TOA, and what they are abbreviations of the three formulas that we're going to use, and we write them out together when we're solving the problem. It's not just to remember the formulas though, it's going to help us select which one to use. I've got a couple of problems or examples that I'm going to demonstrate this, and I'd really like you to do it this way too. So here's a kind of typical, just a triangle question. There's no story to it. Let's calculate the length of CD. Well, I suppose I should, in order to do this, I should really have put in some letters. So I'll do that so that it makes sense. C, D, and E. So we've got this side marked X that I've used to help me solve the problem. And what I would do with my normal trig pattern is I would label the sides. Opposite the right angle is the hypotenuse. Opposite the marked angle is the opposite, and the other side is the adjacent. So I've got my three sides, and then what I'm going to do is write out SOH CAH TOA. I'm going to show you why. So we're going to write it. I tend to write capitals just so that the letters are clear. You can use lowercase ones if you want. SOH CAH TOA. We write that out. So what we do is you're going to put a little tick above the letters O, A, and H, depending on if you have something written against that side. So if you notice here that we've got the X marked here on this line CD is the hypotenuse. So what I'm going to do is I'm going to tick H for hypotenuse. Now you'll be able to do that twice across this because the letters are repeated twice each. So we put an H for hypotenuse because we've got something against that, even though it's only the letter. We don't need to know the number. We've got the 42 against the adjacent side. So I take A for adjacent, A for adjacent. And basically what it does is it highlights where you've got two bits of information, either sides you know or sides you want, and you are looking for the one where you can tick two ticks rather than just one. Okay. If you end up for some reason having so much information that you've got more than one word having two ticks, you can choose whichever you want. But most of the time you'll find that just one of the three words has two ticks. And the good news is that because that's two ticks, we're going to use CAH, and CAH tells us to begin with cos. So it's a really good way of helping you to identify which ratio to use. And then of course that last thing is the C, A, and H remind us what the formula is. C for cos, the next letter is the top word on the fraction, and the H is the bottom word. So performs two tasks. It helps us to identify which of the three ratios to use, and then it helps us to remember what the actual words are in our formula. We can go ahead then and solve it. X, the angle, is 34 degrees. The adjacent side is 42, and the hypotenuse is our x. So we've got this arrangement here. We've got the fraction has a x on the bottom, so I'm going to multiply both sides by x and then rewrite it. So on the left hand side I've got x multiplied by the cos of 34 is equal to, they cancel out because one's dividing, one's multiplying, 42. And this is the one where I have to do another step of rearranging. I want to divide through by cos 34 on both sides. Why? So that they cancel out and I've just got x on its own. So refresh the equation. I've got x equals 42 divided by cos 34. And that's just a matter of then taking your calculator and working that out, or your phone, or whatever you're using. 42 divided by the cos of 34 is 50.6611. 50.6611 and so on. It says to one decimal place and calculate into CD. If you one decimal place, we're going to cut off that extra 6, so it tells us to round up to 50.7, and it's centimeters, and it says calculate length of CD, so I'm going to change my answer as CD equals 50.7 centimeters to one decimal place. Okay, so the rest of it's hopefully familiar. It's the SOH CAH TOA bit at the beginning, which is new. Let's do a second example, and this time it's a wee bit of problem solving here. Here's an equilateral triangle. It's got a height of 50 centimeters, and it says calculate the perimeter of the triangle. So it seems a bit odd. It doesn't have any information in the triangle, but it does give us some clues in the words. So let's just have a look at a couple of clues. It says that the triangle is equilateral, and that's emphasized by the fact that there's 3 dashes, meaning the sides are all the same length. It's got a height of 50 centimeters, which means you really should be marking in where the height is. Remember, the height goes from the highest point, or the vertex, down to the right angles to the base. So there's our height, and we can write in with the fact that that should be 50 centimeters. 50 centimeters. And then it says calculate the perimeter of the triangle. Now, hopefully you remember that to calculate the perimeter, you'd want the lengths of all 3 sides, and you're going to add them up. Good news is that they're all the same. So if I were to work out, say, the length of that side D, well, that's going to be the same, and that's going to be the same. So all I need to do is to work out one of the lengths and multiply my answer by 3. So where does trigonometry fit into this? Well, as always, we're searching for right angled triangles. With equilateral and isosceles triangles, if we drop that height, then we can make a right angle. And in fact, we've split it into 2 identical triangles. One of the strategies that I've suggested before is actually just redraw half of the triangle. So what I'm going to do is redraw the left hand side and put in some information. So I know that that's 50 centimeters. I know there's a right angle there, and I'm trying to work out D. Now, we're missing anything about angles, and that's because there's one thing that we're supposed to know about equilateral triangles is that the 3 angles are all the same size. We know that the total of all the angles has to be 180, and if you split 180 into 3 equal parts, you get 60 degrees. In other words, you may already know that automatically we can write in 60 degrees in all these angles. So we can mark in 60 degrees here. We can actually mark 30 degrees in the other one, but we're going to keep that out because it's then going to confuse us as to which is the opposite and adjacent. So I'm just going to work with the 60 degrees here. And now I'm ready to use trigonometry to work out D. So let's just check. Here's our hypotenuse. Here's the opposite, and here's the adjacent side. And now I'm going to write out SOH CAH TOA, because this is the new bit. SOH CAH TOA. Now remember what we're going to do. We're going to look at the triangle, and if we've got something on a side, we're going to tick that letter. So look, we've got 50 centimetres on the opposite side, so I'm going to tick O and O, 2 ticks there. And I've got a letter written on the hypotenuse, so I'm going to tick H and H. And look, I've got 2 ticks on so that's the one I'm going to use. The S tells me it's the sine ratio. Sine x equals, the next letter O tells me that it's opposite over, and the H tells me it's hypotenuse. Okay, substitute in all the numbers. The angle X is 60 degrees, the opposite is 50, and the hypotenuse is D. So again, we've got the unknown on the bottom, so we just go through that process again. We're going to multiply both sides by the denominator so that they cancel out. That leaves me with D multiplied by the sine of 60 degrees is 50. I'm going to then divide through by the sine of 60 on both sides so that they cancel out, and I've got D is equal to 50 divided by the sine of 60 degrees, which I could do in my calculator. D is equal to 50 divided by 60. Oh no, it's 50 divided by the sine of 60. Sine of 60 is 57.74. 57.735, which is 57.7. We'll say we'll just use 57.7 what centimeters. Okay. Now, that's not the answer to the question, because the question said calculate the perimeter of the triangle. So, we actually need to answer the question. The perimeter is going to be 57.7 multiplied by 3, which I can work out quite easily. 57.7 multiplied by 3 is 173.173.1 centimeters. Okay, so that's me done a couple of things. I've introduced SOH CAH TOA and how to use it. I'd like you to use that every time at the moment. Don't use your notes. Use this, because you'll not always have the formulas in front of you. So use SOH CAH TOA to try and find the correct rule, and then we're going to keep working on different problem solving questions so that you get used to this trigonometry in mixed questions. Okay, I hope that's been helpful.